The hallway floor is warm under your socks at 11 at night. Your AC has been running for 6 hours straight. The thermostat says 74. You set it to 68, and somewhere above your head, in a space you haven't been inside since you moved in, the temperature is sitting at 140 degrees. Your attic is not protecting your house, it is cooking it. And a $4 piece of cotton cloth solved that 200 years before you were born. $4, 200 years, your contractor knew, he just wasn't paid to mention it. Holmes County, Ohio. I pulled into a gravel driveway on a Wednesday in August. 96 degrees outside, the kind of heat that makes your shirt stick before you've walked 10 feet. I was there to look at a farmhouse. No grid connection, no central air, no window units. I knocked. A man named Eli Miller answered and walked me upstairs without saying much. That upstairs bedroom was cooler than my living room back home, the one I was spending $240 a month to keep at 74. I ran my hand along the ceiling, looking for a vent. There was nothing, no machine, no duct, just old wood and still air and a temperature that had no business being that comfortable. I've been in a lot of houses. I didn't understand what I was standing in. Before this video ends, I'm going to show you Farm Bulletin number 284, written by a professor named Walter F. Schaff at Penn State in 1946. He measured temperature drops of 14 to 19 degrees Fahrenheit in upstairs rooms using no electricity at all. That document sat in a basement archive for 80 years. Not because it was wrong. I'll get to that part. You are not a homeowner in this system. You are a subscription. And the first charge on that subscription is running right now, above your head, all day, every day, all summer long. Here's what they didn't tell you, and here is what it costs you every single month they stay quiet. Go to your thermostat right now. Walk over and look at the number you set last night versus what the house actually reached this morning. That gap is not a comfort problem, it is a bill. A 3-ton central air unit pulls 3,500 watts when it is working hard. 4 extra hours of runtime per day in July costs you between $60 and $90 that month alone. Not because your unit is failing, not because your insulation is thin, because there is a space above your head absorbing solar heat since 6 a.m. and it has nowhere to put it except through your ceiling. Run that number over 10 years. 4 months a year every summer. You are looking at between $2,400 and $30,600 handed to a power company for a problem that should not exist. And your roof. A sealed attic running at 140 degrees softens the asphalt in your shingles from the underside. Granules loosen. The bond between layers weakens. What is rated as a 30-year roof becomes a 15-year roof. The average replacement in the U.S. right now runs between $9,000 and $14,000. Your grandfather replaced his roof once. You will replace yours twice, maybe 3 times. Do one thing right now. Put your hand flat on the ceiling directly above your head. If you feel warmth before noon, your attic is already transferring heat into the room you are paying to cool. That warmth is not staying in the ceiling. It moves through at roughly 1 degree per inch of temperature differential per hour. It does not stop because you turn the thermostat down. It stops when the source stops. The question is not whether this is costing you. It is. Every month. The question is whether someone knew the fix and had reasons to make sure you never found it. The answer to that is why I drove to Holmes County in August and stood in a farmhouse that had no business being as cool as it was. The technique I found there is not new. I want to be precise about that. It has a traceable documented history that goes back further than the country you are sitting in right now. The Romans called it a compluvium, an intentional opening in the center of the roof of a Roman atrium, not primarily for light, but to exhaust hot air and draw cooler air through the lower rooms below. The architect Vitruvius documented the thermal mechanics in De Architectura, written around 15 BC. He described it as a pressure differential system operating through natural convection. 2,000 years ago, on purpose. Move forward to 12th century Persia. The Windcatcher, Badger in Farsi, was a rooftop tower built above Homs across what is now Iran and Afghanistan. It caught prevailing wind at the top and channeled it into the house below through a vertical shaft. The city of Yazd in central Iran has wind catchers that have been continuously functional for 800 years. Not restored, not rebuilt, functional. People live under them right now. I know how this starts to sound. Rome, Persia, 15 BC, it feels like a lecture. I sat through that feeling too, early on. Then I stood in a bedroom in Holmes County and ran my hand along the ceiling, looking for a machine that was not there. The grandfather's name was Samuel Yoder. We were in his barn outside Walnut Creek, Ohio, on a Wednesday in August. 96 degrees in the field we'd just walked through. Inside that barn, somewhere around 80, maybe cooler. He pointed to a small wooden structure at the peak of the roofline, louvered on all four sides, roughly 3 feet square, nothing complicated about it. He said his grandfather built it. His grandfather's father before that. His family came from the Palatinate region of Germany in 1847, and they built the roof the way they had always built roofs. I did not say anything smart. I just stood there and looked at it and felt like I had been significantly overcomplicating my life. I took a photo of it on my phone. I'm not sure why. It was a piece of wood with some slats cut in it. But I kept coming back to that photo for 3 weeks afterward, trying to figure out why it bothered me so much that I didn't know this already. Here is something I have not seen written anywhere else. Samuel's wife told me that every fall, her grandmother took down the cotton muslin strips from the rafters, washed them, and hung them back up before summer. Every year, same fabric reused. She said the fabric sometimes lasted 20 years before needing replacement. $4 a cotton, 20 years of service. She said it like it was obvious. What the Yoder family knew by practice, Walter F. Scoff put into measurable numbers. In 1946, at Pennsylvania State University, Scoff surveyed Amish and Mennonite farmhouses across Lancaster, Berks, and Lebanon counties. He measured temperature differentials in upstairs rooms with and without functioning cupolas. His findings, 14 to 19 degrees Fahrenheit of difference, without a single watt of electricity. I pulled that bulletin from a Penn State Archive box that had not been opened in decades. The cardboard smelled like old paper and something faintly sweet I still cannot name. The document was intact, perfect condition, 28 pages, detailed cross-section diagrams. It had not been classified, not destroyed, just no longer mentioned. Right around the decade, when air conditioning became a product a family could buy. The physics behind why this works is simpler than anything you have been shown. Once you understand it, you will look at your house differently. Hot air rises. You learned this in 4th grade. When air heats up, it expands and becomes less dense than the cooler air around it. Less dense air floats upward every time, without exception, without electricity. Your sealed attic traps that process. Hot air rises in, has nowhere to go, and sits there accumulating heat from a roof deck that can hit 160 degrees on the surface by early afternoon. The attic becomes a sealed oven with no exhaust, and a sealed oven radiates heat in every direction, including straight down through your drywall and into the room below. Think of a wet bandana on the back of your neck on a hot day. It does not cool you because it is cold. It cools you because water evaporating off a surface pulls heat away from that surface as it leaves. The $4 cotton muslin works identically. Cotton absorbs moisture from the cooler night air. During the day, as the roof heats, that moisture evaporates right at the point where radiant heat is entering. It does not slow the heat down, it stops it before it moves. It is not insulation. Insulation slows heat transfer. This interrupts radiant transmission at the source. The University of Florida Extension Service documented passive attic ventilation outcomes in 1943, during the war, years when mechanical cooling was reserved for military and industrial use. Their measurements showed properly configured passive systems reduced attic temperatures by up to 40 degrees compared to sealed attics under identical solar load. 40 degrees, not 5, not 12, 40. Your 3,500-watt air conditioner achieves a comparable result in the rooms below, but it runs on electricity, requires a service contract, and sends you a statement every 30 days. physics does not have a billing department. So why is none of this in the homes built in the last 50 years? That is the question I kept not wanting to answer. Willis Carrier was 25 years old in 1902 when he designed the first modern mechanical cooling system for a printing plant in Brooklyn, New York. The original goal was humidity control for paper stock. Human comfort was not the product yet. By 1950, Carrier Corporation had built that incidental product into a $1.3 billion annual industry. By 1975, more than 50 million air conditioning units had been installed in American homes. The market was built, and the market was most profitable when homes ran hot. In 1972, the American Society of Heating, Refrigerating, and Air Conditioning Engineers
ASHRAE
published Standard 90, the first comprehensive national framework governing residential building energy performance. That standard reshaped how attics were designed and evaluated. Vapor barriers became code requirements in most climate zones. Insulation moved into rafter cavities. And passive ventilation features were measured only by minimum ratios, not by the thermal outcomes they actually produced. The standard did not say, remove your cupola. It simply stopped measuring whether cupolas worked. A single ridge vent and two undersized soffit vents could satisfy the ratio on paper. They did, and every house built to that standard has been running hotter than it needed to ever since. I want to be careful here. I am not suggesting engineers sat in a room and agreed to make your house uncomfortable. I do not believe that happened. What I believe happened is simpler and harder to fight. When passive ventilation is the answer, there is nothing to manufacture, nothing to install professionally, nothing to service annually, nothing to replace on a schedule. So passive ventilation stopped being the answer that got funded. They sell you the problem and the solution in the same aisle. Your shingles are the clearest evidence. GF, Owens Corning, and CertainTeed, the three largest shingle manufacturers in the United States, each publish warranty language with the same clause. Inadequate attic ventilation voids the warranty, not excessive ventilation. Inadequate. They document in their own fine print what sustained heat does to asphalt from the underside. It is on the warranty page, in bold. And then they sell you a 30-year shingle that, installed on a standard sealed attic, lasts 15. After the energy crisis of the 1970s, the Department of Energy funded a wave of residential weatherization research. The directive was to reduce heating costs in winter. The solution, foam wrap seal insulate, worked for January. It made every July since more expensive. The follow-up research on passive summer cooling was never funded at the same level. Weatherization products had an entire commercial supply chain behind them. Passive ventilation did not. By 1985, there was a product for every problem the industry had created. Powered attic ventilators, radiant barrier foil, whole house fans, each generating revenue. Each slightly less effective than what Samuel Yoder's grandfather nailed to his roof peak in the 1880s. His house is still standing. Original cupola. Never needed a product. You cannot reverse 50 years of building code in an afternoon. But you can step outside most of the damage, without a permit, without a contractor, in about an hour. If you think this only works for new construction, this part is specifically for you. Here is the full materials list. 4 yards of untreated, unbleached cotton muslin at $1 a yard. 1 roll of aluminum window screen mesh at $3. A staple gun you probably already own. A flashlight. $7 total. That is everything. Step 1. Get into your attic before 9 in the morning. Bring the flashlight. Find your Gable vents. The opening set high on the two short end of your roof line, on the walls, not the roof surface. Look at them from inside the attic. You need clear daylight visible through the screen. What you are looking for: block screens, bird nests compacted against the mesh, or spray foam across the back of the vent. A previous owner may have sealed it on the advice of an energy auditor. It needs to come out. If you find foam, cut it out. Use a utility knife and work slowly. Your house has been sealed up like that, possibly for decades. Let it breathe again. Step 2. If the screen is rusted, brittle, or coated in enough dust that air cannot pass through freely, pull it out and cut new aluminum mesh to fit the frame. Press it in and staple it on all four sides. Aluminum mesh with approximately 1/8-inch openings keeps out wasps, starlings, squirrels, and most bats while maintaining full airflow. 20 minutes. That might be the highest value 20 minutes you spend on this house all year. Step 3. Cut a piece of cotton muslin to cover interior face of the gable vent on your sunny side. In most of the continental US, that is the south-facing end of your house. Staple it loosely against the vent frame. Leave an inch of slack, some drape. You want it to hang, not stretch flat. Air passes through cotton easily. What the fabric interrupts is direct radiant transmission through the vent opening on a hot afternoon. Eli Miller's uncle in Mount Hope, Ohio, has been doing this exact thing for 40 years. He told me his attic in August runs about 18 degrees cooler than his neighbor's. Same road, same elevation, same roof pitch. Step 4. Create the nighttime draw. After the sun goes down, when outside temperature drops below 80 degrees, open your lowest windows on the shaded side of the house 2 to 4 inches. Both gable vents are now clear. The hot air that accumulated in your attic all day will begin moving toward those vents and out. Cooler outside air pulls into the lower rooms behind it. By morning, the wood framing of your house has released most of the stored heat from the day before. Your air conditioner is not starting the day against a building that has been marinating in its own heat since noon yesterday. Before you do this, someone is going to tell you that opening your attic to outside air invites moisture. I heard that too. The Amish have been doing this in Lancaster County, where summer humidity runs above 80%. For 2 centuries, their original hand-hewn beams from the 1860s are still dry and sound. Moving air does not create moisture problems. Trapped air does. There is a difference. Step 5. I did not find this step in any building manual I have read. Eli Miller's uncle showed it to me, and I later found the physics of it in Scoff's own measurements from 1945. Run 1 electric burner on your kitchen range on its lowest setting for 40 minutes in the early evening. Kitchen window cracked 4 inches. A window on the opposite side of the house cracked 4 inches. The small heat differential from the burner creates a localized pressure drop in the kitchen, then accelerates air through the adjacent rooms. The cost of 1 burner on low for 40 minutes, 4 cents. I want to be honest about something. The first time I tried this, 4 summers ago, not last summer, I opened both windows on the same side of the house. Same wall, no pressure differential across the structure, nothing moved. I sat there watching a thermometer for 45 minutes and felt like a fool. I called Eli Miller's nephew the next morning. I described the setup. He listened for about 20 seconds. Then he said, "The air needs somewhere to go to." That was all. 5 words. That was the fix. Now here's what I promised you at the beginning of this video. Farm Bulletin number 284, Walter F. Scoff, Pennsylvania State University, 1946. On July 14, 1945, Scoff stood in the parlor of a working farmhouse near Ephrata, Pennsylvania. Outside temperature, 92 degrees. He brought an anemometer, a device that measures airflow, and held it in the center of the room. No fan, no powered ventilator. A wood stove burning low in the adjacent kitchen, and 2 windows open on opposing walls. He recorded a sustained airflow of 2.5 miles per hour moving through that parlor. 2.5 miles per hour, continuous, on a 92-degree July afternoon in Pennsylvania. That is the difference between a room sitting at 82 degrees and a room sitting at 74. It is the difference between sleep and not sleeping. That document is in the Penn State Archive system. Page 11 has the measurement table. I held it. The data is there. Jacob Hostetler in Strasburg, Pennsylvania, has never replaced his roof. The house was built in 1923. His neighbor down the same road replaced his in 2008, and again in 2019. Same county, same weather pattern, different attic. One of them knew something the other one was never told. Samuel Yoder said something before I left that I have not been able to shake. He said, "We do not think of the cupola as a technology. We think of it as a decision." the decision to not need anyone's permission to stay cool in your own home. I sat in my truck for a few minutes before I started the engine. I did not have a good answer for that. That is not circumstance. That is 100 years of compounding evidence on one road in Lancaster County, Pennsylvania. What Schaff measured in 1946 was not a new discovery. The Amish families he surveyed had inherited the technique from parents and grandparents who built the same way going back to the 18th century. It was not arcane knowledge, it was standard practice. Then the standard changed. The people who shaped residential building codes starting in the 1970s were funded through trade organizations, research grants, and standard-setting committees by the same industries that sold heating and cooling equipment. What passive ventilation needed to function was air, movement, and a correctly placed opening. None of those can be manufactured. None generate a return on investment. None require a service call. It was not buried because it failed. It was buried because it worked. If you believe the knowledge to live well in your own house should belong to you, not to the company that installed your last roof, not to the utility that reads your meter, you already know what to do this weekend. Get a flashlight, get into your attic, leave me a comment with your state, your house's age, and what you find up there. Open, blocked, foamed, painted shut. I read every comment on these videos. The next video is about something that took me longer to find and made me angrier when I did. Root cellars. Specifically, why the same building industry that sealed your attic also stopped building root cellars. I found a paper by a Swiss engineer named Johann Rudolph, published in 1811, describing how to maintain a steady 52-degree underground temperature year-round, with no moving parts, no electricity, and no service contract. The Amish in Holmes County still have their root cellars. They still have their cupolas. They still have their gable vents, unblocked, doing exactly what they were built to do 2 centuries before your last power bill arrived. When you understand what Rudolph documented in 1811, this video will look like the easy half of the problem. Some knowledge survives because certain people refuse to let it be sold back to them, one product at a time. That roof above your head is still waiting.